Okay, so derivatives of log function. Okay, so these are formulas you actually should already know. What's the derivative of e to the x? E to the x. It's your favorite one, right? It's my favorite. What's the derivative of a to the x? And technically, you don't need both formulas, right? Because if you use the second formula with e, ln of e is 1, and so you have ln e to the x is, what we know. So, yeah, there you go. Okay. So using those formulas, we're going to find derivatives for logarithmic functions. So natural log of x. So we start by taking this. It's almost the exact same trick as the inverse trig function. So with inverse trig function, we had like y equaled tan inverse, and we said, okay, tan y equals x, right? With this one, we're going to say, okay, e to the y equals x. Does that make sense? If I e both sides, I get e to the y equals e to the ln x, which just gives me back x. And we're going to use the implicit differentiation trick again. So what's the derivative of e to the y? Times dy dx, spectacular, equals 1, exactly. So then dy dx is 1 over e to the y, which is 1 over x. Yep. So if I say, okay, what's the derivative of natural log of x? You say its derivative is 1 over x. And it's the same trick as the previous ones. How is log base a, yes?
If we're like writing down like a quiz or a test, do you want us to put that final like dn or d over dx equal ln x equals 1
Well,
over
if you
x?
don't put the d over dx, it's actually not, that's just me stating what the formula is. But technically, if you wrote ln of x equals 1 over x, that's not correct.
Okay.
Like they're two different functions. It's that the derivative of one equals the other. Does that make sense? Without the derivative operation, you claim two things are equal that are not. It'd be kind of like saying x squared equals 2x. That's not true, right?
Yeah.
It's the derivative of x squared that's equal to 2x.
That makes sense.
That makes sense? It's the operation that makes the statement true. Okay. Good. It's a mistake that happens. So log base b. So in the previous one, I used e to the y. This one, I'm going to use b to the y. Why did I choose that base? Because they're the same number, and those, and on the right hand they cancel, right? So I get b to the y equals x. It's the exact same. It's just b and not e. All right, that's always different. So what's the derivative of b to the y?
ln b e to the y dy.
Great. ln b to the y dy over dx will once again equal 1. No, it's definitely ln. Yeah, kind of like the formula you wrote for the a above was ln.
Okay.
ln is a specific kind of log. It is log base e. So if you get the dy dx alone, you'll have 1 over ln b times b to the y. Yep, exactly. It's 1 over ln of b times x. There's kind of a parallel here, isn't there? Other than this ln of b in its denominator, the formulas aren't the same, right? So here's the parallel that I mean. Well,
Why is it not correct just to have ln b times b to the y? Why did you substitute that x?
Because b to the y equals x.
That's why you do it, but otherwise it wouldn't be a formula that you could like use as readily.
Use for something else?
Yeah, use for taking derivatives of related things, where you always have to do this sort of process, so. Okay, so here's what I wanted to say. The derivative of e to the x is just e to the x, right? The derivative of b to the x is ln b, b to the x, right? The derivative of ln of x is 1 over x, and the derivative of log base b is 1 over ln b x. Do you see how these two are kind of similar and those two are kind of similar? And the same vein, you see how the ones that have these both involve ln of b in them, right? And technically speaking, this formula would also work if your log was base e, because you plug in ln of e and you get 1. So, I believe, I'm 99.7% sure that that is the extent of the differentiation formulas you have to memorize. Okay, there's other stuff we're going to do that uses these formulas, but that's the ones you have to memorize. Log functions are the last. So, yay. Only 12 flashcards later. Nothing. So the derivative of natural log of x is 1 over x. The derivative of log base b, x is 1 over ln b times x. And I think I see what Mary Kate was asking now. Even though the formula involves log, it is still ln in the derivative. That's what you were asking, right? Yep. Okay. Alrighty. So what's the derivative of ln of stuff going to be? 1 over stuff times stuff's prime, right? So y prime will be 1 over stuff. The stuff just happens to be something that isn't just x. Times, what's stuff's derivative? 8x. So the derivative is 8x over 4x squared plus 5. Bam, there you go. Just a new formula, same concept. Just that where the stuff goes is different because the function's different. Okay, how about this one? ln of tan. Y prime will be
1 over 10x times secant squared.
times secant squared x. So y prime is squared x over tan x. Could I rewrite that with just sines and cosines, just for practice? Let's just do it for practice. That's 1 over cosine squared x divided by sine squared, oh, not sine squared, sorry, divided by sine over cosine. What happens to the denominator? Because you're dividing by it, it gets flipped, reciprocated. So you've got 1 over cosine squared x times cosine x over sine x. Or that's looking to be 1 over sine x cosine x, right? I would have to ask you to do that. Does that make sense? Like if I wanted you to do it, but it's just good to know that it's possible. Okay. Never mind, not that one. Ooh, log base 10. Ooh. So f prime of x. I'm going to show you 2 ways to do this because we're going to get an answer that seems kind of funky, and I'll explain it 2 ways as to why it is what it is. So the first way is the harder way, but probably the way you're going to see more intuitively. So the derivative of log base 10 of stuff is 1 over ln of 10 of the stuff, right? Times the derivative of the stuff. That's the chain rule, right? Okay. Okay, what's the derivative of x to the 1/2?
1 over 2 root x.
Is it okay if I skip to 1 over 2 root x for the rest of you? Because the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Do you guys see what Rachel did in one step? Just set the negative down. And what happens if you multiply that root x by the other root x? you just get x, so it becomes 2 ln 10x. So there's f prime. Here is the better way. Notice that this is log 10x to the 1/2 power, right? What is the purpose of a logarithm in life? Take down exponents, to be annoying and take down exponents. So, oh, that kind of goes together, right? It takes stuff down, it's annoying. So it's 1/2 times log 10x. And notice that's still the original function, it's not the derivative yet. Now, is taking the derivative going to involve the chain rule? It won't, will it? So f prime of x will be 1/2 times 1 over ln 10 times x. And is that the same answer that we had before? Do these match? They do, because you can just multiply across and just say, okay, well, I have 1 over 2 ln 10 times x. So the moral of that story that I want you to be asking yourself when you're looking at your logarithms is, can I expand before differentiation? Because if you do it, it will make taking your derivatives easier. Could we have expanded example part A of this example? I think I remember what part A was. Part A the one that was, I'm just going to go. How about this one? Log base 2 of cosine. So g prime will equal 1 over ln of 2 times cosine x times negative sine x. So that's negative sine x over ln 2 times cosine x. That's a totally acceptable answer. Is it also clear that that's negative tangent of x over ln of 2? Because you got the sine over cosine making tangent. Either one's fine. Okay. How about this one? What rule do you have to use? Chain. And the outside function is which function? The root function, the 1/2 function. Yep. So f prime of x will be 1/2. Stuff inside remains unchanged. New power is times the derivative of the inside stuff, which is just ln x's derivative is 1 over x. What happened to the 5 when you took the derivative of the inside? It's 0. Okay, good. So that's 1 over 2 root 5 plus ln of x times 1 over x, or 1 over 2x root 5 plus ln of x. No matter if I ask you to get a common denominator or not, I'm always going to have you rewrite negative exponents, just to make sure you can go back and forth. Okay. Alrighty. Not so bad, right? Same as last time, just different formulas, right? Same rules, just different formulas. Find the domain of f. I probably meant to say f and f prime. Let's just look at f prime. Okay, so for f prime, is it clear that x can't be 0? That's because of the whole x thing, right? Is it also clear that 5 plus ln of x has to be bigger than 0? And I mean bigger than, not equal to. And the whole reason there's no equal to is because that expression's in a denominator. Okay, so then solve that. We have ln of x is greater than negative 5. And how do you undo the ln? E it. So x must be bigger than e to the negative fifth, which is the same thing as 1 over e to the fifth, right? How, so this is okay with the solving part there? How does 1 over e to the fifth compare with 0? Is that bigger than 0 or less than 0?
Bigger than 0.
But not much, but it is bigger than 0, right? So this domain is 1 over e to the fifth to infinity. And the fact that x couldn't be 0 doesn't matter because it's not included in that interval anyway. Does that make sense? If we would have had like x can't equal 1, we would have had to leave the 1 out of that interval that we just found. But because 0 wasn't in there, don't need to worry about it. It's already excluded. Just got excluded twice. It didn't get invited to the party 2 times. No one likes 0. Poor 0. Teeter. 0 is my favorite number, so I'm gonna always invite 0 to my parties. Because I'm Ellen and I'm cool. All right, differentiate f and find the domain. I must be f prime. I don't know what I was thinking. Okay, so what rule do you have to use here? Quotient. Okay. So, and I don't think you could make it product, but I think that makes it uglier, so I'm just going to vote for quotient. So it'll be low d high, which is 1, right? Minus high d low. Okay. Well, the 1's derivative is 0, right? The other stuff will be negative 1 over x plus 1. Technically, you must use the chain rule, but what is the derivative of x plus 1? Just 1. So on that particular question, if you had forgotten the chain rule, I'd be none the wiser. Okay? And all that jazz is over 1 minus ln of x plus 1 squared. Okay, so you've got 1 minus ln of x plus 1 plus x over x plus 1, all divided by 1 minus ln of x plus 1 quantity squared. And this is the whole how to get rid of fractions trick that we discussed earlier today before your quiz is a really good one. So how would you get rid of this whole over x plus 1 business? You could take and you could multiply the whole numerator by x plus 1, technically over 1, denominator by the same thing. Does the over 1 really matter? No. But that's going to give you x plus 1 minus parenthesis x plus 1 ln of x plus 1 and then plus x all over x plus 1 minus ln of x plus 1, that whole thing squared. And I apologize for the length, but let's simplify it just a little bit more. What can you combine in the numerator? The x's. So 2x plus 1. I'm just going to leave it as minus parenthesis x plus 1 ln of x plus 1. All over x plus 1 minus ln of x plus 1, the whole thing squared. So there's your derivative. Are there any super obvious things you have to leave out with the domain of f prime? X can't be negative 1. I took care of the first factor. Now, does it also make sense that 1 minus ln of x plus 1 is going to have to be not equal to 0 as well? Does that make sense? So 1 will equal ln of x plus 1. E equals x plus 1. And that's going to be x is e minus 1. So x cannot equal e minus 1. So there's two numbers we're leaving out. And what's the final thing you have to worry about? Ln in a negative number, exactly. I know that's what you meant. So also, x plus 1 has to be bigger than 0. Does that make sense? And that's because that's what's inside your ln, and the third commandment in math class is thou shalt not log negative or zeros. So that means x has to be bigger than what number? Negative 1.
I'm surprised. Math is the only science where you can definitively prove things, and yet we still need commandments.
Well, I mean, there's reasons, but it's easy to remember them. I think it's just me that has those. So negative 1 got left out twice, right? Okay. So, but your interval has to also leave out e minus 1, which is about 2.71 minus 1, so 1.71. So your interval will be negative 1 to e minus 1 union e minus 1 to infinity. And that's tricky because you have to account for a lot of things there, right? You've got two things in the denominator that could be 0, plus you have an ln in the denominator. It's just kind of a lot. So it might happen on like a homework question, but probably won't come up on a quiz because it's just so involved. Maybe a final if I like was also, well, but maybe it wouldn't be quite so bad, right? But it's also testing, can you find domains, right? Which was part of the first unit, yes? If you remember your commandments, you got it. There's 3, it's not as hard as life, there's just 3 commandments. Okay. Now, here we go. Here's where I want to get into the can you expand it thing. So this one, can you expand anything, pull anything down? You can, because this is actually natural log of 5x plus 2 to the power of 1/2. And one of the purposes of natural log in its little life is to pull down powers. So that's 1/2 ln 5x plus 2. And I'm okay to say equals because it's still the original function. It's just written a different way. The second I take a derivative, what do I have to write? F prime. So you can tell me, okay, this is my derivative now. So it'll be 1/2 times 1 over the stuff. And because the stuff has more than one term, it's got to be in parentheses. And because of your chain rule, what do you multiply by? Which is 5. If you didn't see that, what would have happened is f prime would have been 1 over the stuff, right? Does that make sense? Times 1/2 stuff to the power of negative 1/2, right? And then times what other thing? 5. Which would be 5 over 2 times root 5 plus 5x plus 2 root 5x plus 2. It's the same thing, right? I just think that my way is easier. Do you agree? Say that again?
Yeah.
Yeah, you agree? So, and it will be impressively easier when you have ln of like a ratio or a product. So we'll get to what I mean by that in just a second, but if you can expand, expand. That's why I went over that in the first unit, because I knew you were going to need it. It wasn't just to torture you. Okay, if I didn't expand here, I'd have to do the product rule on the stuff inside, right? If you expand, you can make this into log 5x squared plus log 5 root x plus 1. No more product rule. And you still have to chain rule unless you're smart and you observe, oh, the log's purpose in life is to pull down some powers, right? So he's going to pull down that 2 and pull down that 1/2. And logs are special that way. Trig functions don't work this way. You know, it's logs that have this property. you see how taking the derivative all of a sudden got a heck of a lot easier? Yeah. So g prime of x will be 2 times 1 over, what has to go in the denominator because it's log 5?
It's ln 5 times 5 to the x.
Nope, ln 5 just times x. Just like ln x's derivative is 1 over x, this just is also 1 over x, just with additional ln 5. Plus 1/2 times 1 over also ln 5. What else has to be in that denominator?
X plus 1.
And then technically you need the chain rule, but what's the derivative of x plus 1? 1. So on this question, I would like you to get a common denominator. I do believe it's not super hard. So if I do require that, what do you need to multiply the first ratio by for your common denominator? 2 over 2, and also,
X plus 1.
yep. And the second one just needs to be multiplied by x over x. So that's going to be 4x plus 4 plus x over 2 ln 5 x times x plus 1, or 5x plus 4 over 2 ln 5 x plus 1. Is it clear where I got the whole 4x plus 4 business? Okay. The point is, if you see a log of a fraction, or, you know, a product, expand it first if you think about it, because it will make your life a lot easier. If you'd done it the other way, it would sort of simplify to this if you were patient enough, eventually. It's just gonna, and there are lots of room for error in the simplification process, which is why it's easier to expand first, even with the common denominator step. Okay. Like this guy, if you didn't expand, you have to do 1 over stuff times the derivative of the inside stuff, which would involve the chain rule, the product rule, and the quotient rule. I wouldn't actually do that to you, would I? What I'm testing is, can you figure out that this actually is expandable? Can you guys expand in one step? Are you capable of that? Think so? Okay, so then we're going to have an ln of x, right? Plus 2 ln x squared plus 1. Will the next sign be minus or plus? Minus. And there'll be a power of 1/2 that pulled down, ln of 2x to the 4th minus 5. Does that make sense? Okay. On this one, we're not going to get a common denominator in the end. We're just going to take the derivative. So f prime of x will be 1 over x. That one's just easy, right? Plus 2 times 1 over x squared plus 1 times, what from the chain rule? Almost. 2x. That makes sense? Because x squared's derivative is 2x. And then minus 1/2 times 1 over 2x to the 4th minus 5 times,
8x to the 3rd.
great. And then just simplify a little bit, like, you know, put your numerators together, is all I'm asking. 1 over x, 4x over x squared plus 1, right? Minus 4x cubed over 2x to the 4th minus 5. Getting a common denominator wouldn't be super awful, right? Just multiply each fraction by the other two's denominators, but it's more algebra than I want to make you do right now. The important thing is, okay, expand those logs, then take derivatives. All right? Crazy, huh? Okay, on this one, can that 5 pull down? No. So it has to be, the 5 will pull down if it's ln of x to the 5th. That's when the 5 pulls down. The reason is that comes from the addition rule, and multiplication is repeated addition. So on this one that we have, the fifth power is outside the ln. Okay, so this means we have to just use the chain rule. We get 5 ln of x to the fourth times. Some people write this like this, kind of like the notation that's used for sine and cosine. I've never seen a textbook use that, but like Latrice used it in her Math Bridge course, I think, perhaps. And also, just I'm not sure if WebAssign will take it like that. Do you see what that's trying to say? So I'm not sure if you should do that or if you should do 5 and put parentheses around your ln of x to the fourth. So the parentheses are important, otherwise it would mean the x was to the fourth and not the whole thing. Either that, or I'll know what you mean if you do that, but I think it's a little bit less standard than the notation for sines and cosines. So, okay. Now part B is different, right? No parentheses now. So now can the power pull down? Yes. So now this is 5 ln of x, and f prime of x is just going to be 5 over x, right? Okay. Would you get the same thing if you didn't see the expansion?
Yes.
Yep, and it would be a little bit harder. You'd have 1 over x to the fifth times 5x to the fourth, which then simplifies to that, right? Because the x to the fourth cancels with 4 of the x's in the bottom, giving you just a 1 over x, right?
Probably make a mistake on that
Yeah, exactly, which is why it's easier to see. If you can pull down powers, do so. It's easier. Okay, so this one has absolute value bars, which we haven't seen yet, right? So the commandment is thou shalt not log negatives or 0, right? But if you take the absolute value of x first, all of a sudden you can plug the negatives in. Does that make sense? Okay, so you have two cases. If x is positive, the absolute value of x is just itself, right? Do you buy that? Okay, so in this case, if y is ln absolute value x, that's the same thing as ln regular x, and y prime is 1 over x. Okay, if x is positive. Okay, part 2 is if x is negative, then absolute value of x is negative x. You can think about that two ways with a number. If I absolute value negative 3, it's the same thing as negative 3, right? That's how you make a number positive, is you negate it, right? Or you can think about the function absolute value of x. It's that V-shaped curve, right? This side of it is y equals regular x, right? This side of it is y equals negative x. So when you're on the negative side, you're that part. And because that x has a built-in negativity, taking the negative in front of it's going to make it positive. You just don't know what that number is. You don't know if it's negative 3 or negative 5 or negative 10, just like it's something that's negative. So in that case, you can say ln absolute value is the same thing as ln of negative x. And because x has a built-in negative bit, negative in it makes it positive, so that's okay. Now take the derivative and use the chain rule. We'll get 1 over negative x, right? Times what from the chain rule? Negative 1, which is also 1 over x, right? So for this function, ln of absolute value, y prime is just equal to 1 over x, and the absolute value bars are gone. And that's because the absolute value bars have built in two cases, the positive case and the negative case, and the answer was the same when you looked at both of them. You still can't plug in 0, but with this thing, you cannot plug in negatives. But the reason why it's just 1 over x is a bit technical, but the moral of the story is the absolute value bars go away, and that's not a lie. So the ABSs go bye-bye. Very technical term. Bye-bye. Bye-bye. See you later. Adios. Hej då. That's bye in Swedish, in case you were wondering. До свидания. See you later in Russian. Okay, so this one. F prime of x will be 1 over stuff. And And I'm gonna test your differentiation formulas, because you gotta know derivative stuff. Oh, man. Secant x, tan x, we need flashcard stuff.
And the secant squared x.
Uh-huh. Okay. Is there a greatest common factor in the numerator?
Secant x.
Secant x. Oh. Huh. Anything else that can happen? Cancel. Yeah, look at that's just secant x. Don't be freaked out if that happens on your homework, okay? Like this, I'm assigning problems on purpose. So sometimes things will simplify down a lot. And it has to do with like we're gonna do later in the class where we're gonna go backwards and talk about, okay, we have this function. What function was differentiated to give us this function? We're gonna go backwards. Kind of like in algebra, you first multiplied and then factored, right? We're gonna first take derivative and we're gonna go backwards derivative. It's called an antiderivative. We'll do that later. Yeah. It's called antidifferentiation. Okay, and the last technique, oh, let's see. I think I'm gonna have to hold up on logarithmic differentiation because of our like